Right, we're looking at calculus differentiation. This was on your quiz. Right, the first one we have to differentiate e to the power 2x. All right, so that's an exponential function. How you derive exponential functions. Right, this is the rule of deriving exponential functions. All right, e to the power u equals, the derivative of e to the power u is e u multiplied by the derivative of u. All right, so let's bring our question here. We have e the power negative 2x. So our u is negative 2x in this case. Okay, you would say u is negative 2x. All right, then we have to derive u. So you say u prime, right? First derivative, right? We are using the power rule. All right, remember this x is like x to the power 1. All right, so here we're deriving with the power rule. We're going to say 1 times negative 2, that is negative 2. All right, then 1 minus 1, that is 0. So we have negative 2x to the power 0. And x to the power 0 is like 1. So we just have negative 2. So the derivative of e to the power u is going to be e to the power negative 2x times, this dot is times multiplication, right? Times negative 2. And we can rearrange it as negative 2 e to the power negative 2x. All right. And we can properly put it like this, negative 2 over e to the power negative 2x. Oh, e to the power 2x, because once it comes as the denominator, it becomes positive. So we have negative 2 over e to the power 2x. Any questions, queries, clarifications? All right, we go to the next one. We've got y equals, yes.
Just a quick one. I don't know. Can you just run through again? Just a quick one, though.
Right. So whenever you're deriving exponential functions, where you have this e, right, where you have this letter e, this is the principle you have to use, all right? The derivative of e to the power u is equals e to the power u times the derivative of u, all right? So basically what you have to do is, in your question, you just say, okay, what is going to be my u in this case, all right? What is going to be my u? All right, in this case, our u is negative 2x, all right? It is negative 2x, okay? Now, we have to derive u, okay? And we'll derive it using the power rule, all right? The power rule, remember, x to the power n. Let me just also write the power rule so that we also remember it too. The power rule is x to the power n and all right, equals n times x, which is nx here, to the power n times x to the power n minus 1. Yes. All right. Meaning this exponent, which is n, you multiplied by the coefficient of x. All right. In this case, the coefficient is 1. All right. The coefficient is just a number before the variable. The variable is just these letters, x, y. Those are variables. So you multiply the exponent with the coefficient. All right. That's why it's n here. And then the exponent you subtract by 1. So if we apply that to this one here, u equals negative 2x, when we derive it, the exponent of our variable x is 1, right? So using the power rule, we multiply our exponent times our coefficient. All right? We multiply our exponent, which is this power 1 here, with the coefficient negative 2. 1 times negative 2, you get negative 2. Then remember our exponent, you also have to subtract it by 1. 1 minus 1, it is 0. Okay, and you remember from indices that x to the power 0 equals 1. That's how we've got our negative 2 here. All right. Then after you've done that, you just substitute here. All right. So e to the power negative 2x equals e to the power negative 2x times the derivative, which is negative 2. Are we okay up to there, Miss Tunosua? Are we okay up to that point?
Yes, sir.
All right. So after that, you just rearrange your answer. All right. It's negative 2e to the power negative 2x. Then you remember, whenever you have a negative exponent, you get its reciprocal. All right. Meaning this e will just come down. All right. It will come to the denominator. Okay. The reciprocal of any number or any variable, all right, the reciprocal of e to the power negative 2x is 1 over e to the power negative 2x. E to the power 2x. All right. So that's how this negative 2 remains at the numerator and this comes at the denominator. So you have to remember these laws of indices. Okay. If you have a negative exponent, always get its reciprocal, meaning you just put 1 over the same number or variable. All right. Yeah. So this is how we put our answer: negative 2 over e to the power 2x. Okay. So maybe you can write down this rule for exponents. You can also write down the power rule here because these rules will always you always see them taking place. All right. Especially this power rule. So just write these two rules down. Okay, because as you can see in this third question, we have another exponential function here. All right, so just write these two down. Yeah. Any clarifications before we move to the next one? Deriving trigonometric functions. Okay, can I erase? Can I erase? My science means yes. Science means yes. All right, the next one, all right. What y equals.
Sure, sir.
Okay, we have y equals sine, open brackets, x squared minus 1. Right here, this is the chain rule which we're going to need to do. Right, so remember the derivative of sine, okay, the derivative of sine x, all right, sine x or sine u, all right, let's choose u because I like using u a lot. Right, so the derivative of sine u, okay, is cos u times the derivative of u. All right, the derivative of sine u is cos u times the derivative of u. Okay. So what is our u in this case here? For number 2, u is x squared minus 1. Right. U is x squared minus 1. So you say your u equals x squared minus 1. Right. Then the derivative of u, right? Again, the power rule comes into play. Have you seen? We've got x squared here. Our exponent is x. All right. So we multiply our exponent times our coefficient. Our coefficient is 1. 2 times 1, it is 2. And then we're going to subtract 1 from our exponent. Right. So 2 minus 1, that is 1. Right. So we have 2x. We just have 2x. Right. Then the derivative of a constant or a number without a variable is 0. It disappears. So this 1 disappears. All right. So our u prime or the derivative of u is 2x. All right. So if we use this principle on our question, we say sine, okay, sine x squared minus 1, right? We say the derivative is cos u, so we say cos, okay, our u is x squared minus 1 times 2, right? So whenever I see I put a dot, it just means multiplication, all right? That means multiplication times 2x, all right? So your answer is going to be, we'll rearrange this, we're going to have 2x cos x squared minus 1. Queries, clarifications? Questions, clarifications? Are we okay with this? Mrs. Barbara, Miss Tunosiwe, Miss Lufunda. Who else? Who else is here? Miss Lufunda, are we okay with this?
So for me, I'm a bit behind.
You all okay? Yeah, on what? On differentiating trigonometric functions.
Yes, sir.
All right. So trig functions, they've got their identities when you differentiate them. Remember that the derivative of sine is cosine. All right. The derivative of cosine is negative sine. You have to remember those. You have to remember those identities. All right. I believe I sent a document which shows all those identities. Do we have that document? If not, I have to send. So you have to know those identities, okay? Then whenever you're differentiating trig functions, all right, you're always going to have a function attached to the trig function. So here it's this, in this case, it's this x squared minus 1. All right. So you, what you're supposed to remember is you have to remember the principles when you're deriving trig functions. The derivative of sine u is cosine u times the derivative of u. So you, what you have to, all that you have to do is you just have to determine what is my u in this case. Okay. And we found that our u is this x squared minus 1. Once you find your u, you derive it using the power rule. All right. So 2x squared minus 1, we derived it using the power rule. We got 2x. That's our u prime. Then all you have to do is just substitute. Cosine u is cosine x squared minus 1 times the derivative of u. You should also notice a trend here. It's the same way we also dealt with this exponential function. All right. When you're deriving it, you're going to write the same exponential function unchanged, and then you derive u. Only difference with the trig functions is you have to derive first the whole function, which gives you cosine, then you derive u inside. So I'll give you questions to practice on this, because with this, practice makes perfect. You have to just do more questions on this. That's how you get the 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 logic behind it. All right, you have to know how to derive cosine, trigonometric functions, exponential functions, the natural log. You have to know how to derive these three things. So we'll do more practice questions. All right, here just hang on, just just get the principles. Here I just want you to know these principles. These are which I'm highlighting here, like for exponential functions. Just remember this principle. As I haven't told you, write it down, all right? Because when you're dealing with these type of functions, you have to look at this, and then you compare it to your question. Similar with trigonometric functions. Just write this down. The derivative of sine u is cosine u times the derivative of u. You write it down on your paper there. All right? So that the next questions we are trying, they'll be similar to this. So you have to use these as your guidelines. Right? Unfortunately, there are no other shortcuts. You just have to know how to derive these things. There's no other way around it. Okay? There's no other way. Okay. So we'll do more practice questions here. Here I just want to show you how to do it, and then yeah. All right. So we'll do more practice questions, Mr. Nose, okay? So that you're no longer lost. Any other queries? Okay, let's do question 3. So please write these down, which I've highlighted. This one in blue and this one in green here. Just highlight them. Write them down. Right, then question 3 here, we have the y equals e to the power x times the natural log of x. All right, so here the product rule is going to come to play. Why? Because we've got different types of functions. We've got an exponential function and with the natural log. All right. So that's when you know that, oh, here is where I have to apply the product rule when you have two different functions together. All right, please write that down. All right, when you've got two different functions or expressions which are together, you know how you have to use the product rule. All right, we've got two different functions or expressions that are combined together. You have to use the product rule. So please write that down. All right, then also here's the principle for deriving the natural log. Dy dx. Oh, actually, it's not dy, du dx. So it has to be du x, not dy. Right. So for a natural log, all right, natural log of x, natural log of u, actually, natural log of u, natural log of u. The derivative of the natural log of u is u prime over u. All right. Meaning you have to derive your u, all right, and put it over u. Okay. So I will illustrate this with this natural log here. All right. So let me just erase this part too. All right. So here we have the product rule in play. So the product rule goes like this: the derivative of f times g. F and g are different functions. All right. Equals to f prime. Whenever you see this prime, it just means the derivative, all right? The first derivative, all right? This prime here just means you have to derive f, right? F prime g plus f g prime, all right? Can we also write this down? This is the product rule. Whenever you have two different functions or two different expressions, f and g, it equals f prime g plus fg prime, meaning you have to derive f without deriving g. Then you add f. You don't derive f this time, you derive just g. All right. What's happening here is you derive one function, you leave the other one. All right. In the second case, you leave one function and derive the other one. All right. So here you derive f, you leave g. Then you're going to leave f and derive g. All right. So you're going to choose what is my f and what is my g. So you say, okay, my f is going to be e to the power x. All right, f is e to the power x. Let's derive e to the power x, f prime. All right, we go back to our principle here on top. The derivative of eu equals eu to the power u prime. So what is our u in this case? Our u is x. When we derive x, right? Remember, this x is like x to the power 1. So we're going to derive this x. 1 times 1, it is 1, right? Remember, the exponent, you're multiplying it with the coefficient. The coefficient is the number before the variable, and the variable is the letter. So it's a 1 times 1, that is 1, all right? Then you subtract 1 from this x, and remain with x to the power 0. And x to the power 0 is the same as 1. So you still remain with here 1 times 1, which will give you 1. All right. So e to the power x, the derivative is going to equal to e to the power x times 1. Right? Because the derivative of x is 1. So f prime equals e to the power x. Okay. Any queries on that one? Was I too fast? Maybe I go slower. Are we okay with that?
Just come again, sir.
All right.
One more time.
Okay. So the product rule, you use it whenever there are two different functions or two different expressions. All right. This is the product rule here. The derivative of f times g equals the derivative of f, meaning you derive f and you're going to leave g alone, plus f, meaning you do not touch f, you leave it the way it is, and then you're going to derive g. All right, you've got two different expressions, f and g. So it's up to you to choose what's going to be your f and what's going to be your g. Right here we have two different expressions. We've got the natural log and we've got an exponential function. All right. So we'll say, okay, our f will be the exponential function e to the power x. All right. So we're now deriving f, right? And I said that the way you derive exponential functions, all right, the derivative of e to the power u equals eu times the derivative of u. So here in this exponential function here, you're going to say your u equals x, all right? This is your u here, right? The u just represents the exponent which is attached to exponential function. So here, our u is x. When you derive x, the derivative of x is 1, all right? So the derivative of e to the power x equals e to the power x times the derivative of our x here, which was 1. That's how we got e to the power x times 1. Is that okay? Is that okay with you?
Yes.
All right. Then our g in this case is the natural log of x, right? This is natural log of x. So if we want to derive g, which is g prime, all right, we're going to use this principle here. The derivative of the natural log of u equals u prime over u. So what you're just going to do is, okay, what is my u in this case? All right, my u is x. So you say u equals x. You derive u, all right, we've derived x already. The derivative of x is 1. All right. So the derivative of natural log of x is going to be 1, which is u prime over x. All right. It will be, this is the u prime over u. All right. We just substituted u prime over u. So the derivative of the natural log of x is 1 over x. All right. You just determine your u and you derive your u. Okay. That's the secret. You just say, oh, what is my u in this case? When you find your u, you derive your u. All right. So after we've got all these derivatives, it's just a matter of substitution. Okay. So it's f prime. F prime is what? E to the power x. Then what is our g? G is the natural log of x. So we say f prime g. G is the natural log of x. All right. We've derived x. We haven't derived g. We've just left g as it is. Plus f. All right. F. Here we're not deriving f. F is what? E to the power x. Right. Then g prime. We derived it. It's 1 over x. All right. We can also factorize this. We have a common factor here, which is e to the power x. So you just put your common factor outside e to the power x, open brackets, the natural log of x plus 1 over x. That is your answer. All right. We have factorized this expression. We found the common factor in both expressions is e to the power x. That's why we put it outside the brackets, right? Because it's the common factor, right? So that is the answer for the third one. All right. E to the power x, open brackets, the natural log of x plus 1 over x.